Before the announcement, it is important first to recognize what molecular gasoline pedals are. The Large Hadron Collider, by the initials LHC, operated by CERN, is a 17-mile ring built with superconducting magnets. Standing at the world's largest and most magnificent particle accelerator, the LHC represents a pinnacle that shows how much humankind has accomplished. The machine is incredibly powerful. It is capable of recreating conditions similar to those in the earliest moments of the universe. But should the same machine that engineers the unlocking of the secrets of the universe also hold the key to something almost revolutionary? Founded in 1954, CERN has become one of the most renowned research institutions in the world, with 23 member countries and hundreds of scientists contributing to its work. As massive as the LHC is in terms of being the flagship mission of CERN, it is actually only one part of a far-reaching network of fuel pedals and experiments. These experiments are not designed for humans or equipment, but rather for subatomic particles, the better to test the very nature of space and time. The LHC accelerates protons at nearly the speed of light, forcing them into collisions that replicate the energy released during the Big Bang. These excessive collisions generate temperatures which can be some distance hotter than the Sun's center, and an array of magnets facilitates guide the protons on their direction. A state-of-the-art cooling device continues these magnets chillier than outer area. The LHC's beams collide at 4 different places alongside its accelerator ring, interacting with 4 unique particle detectors: ATLAS, CMS, ALICE, and LHCb. Each one has its very specific job of measuring exceptional parts of particle physics. Combined, they are like huge cameras taking snapshots of the outcome of those collisions. The data is collected and then examined as scientists attempt to find the elusive Higgs boson, also called the God particle, along with any anomalies that would illuminate the essential nature of the universe. While focusing on the microcosmic world, we want to unfold the secrets of the macrocosm. Each discovery opens the floodgates to a newer wave of queries. The LHC is much more than just a scientific device. It metaphorically represents human desire to understand and progress further. It really denotes our never-ending effort of reaching out toward the fundamental forces that rule this universe. Yet, even as we extend our knowledge of things, deeper and more existentially profound questions await us in this process. Can there be dangers in this probing of the unknown? Is our quest for knowledge likely to unchain something beyond our grasp? Within CERN, as far as a reach into human knowledge goes, something chillingly awful has cropped up, something that has stopped even the most seasoned scientists in their tracks. Brian Cox, a one-time CERN scientist and expert in particle physics, has recently made an utterance that has greatly surprised and bewildered human beings worldwide. His statements have been apparently shocking but honest. The purpose of the LHC is to simulate a mini Big Bang. Yes, you heard it right, a smaller version of the event which gave rise to our universe. Cox went into detail regarding the profound capabilities of paintings the LHC can make, including earth-shattering discoveries such as revealing the secrets of the Higgs boson and delving into the mystery that is dark matter and its composition, which makes up so much of the universe. It's practically impossible, the idea behind keeping the power to recreate the very forces that birthed the universe. It's a seductive possibility, yet full of risks. The mini Big Bang isn't always only a theoretical concept. It's in real reality within the LHC. The extreme temperatures, pressures, and strength generated in those collisions mimic the situations present on the universe's beginning. It's as even though we're standing on the brink of recorded history, witnessing the very beginning of lifestyles itself. However, with such strength comes an similarly weighty obligation. The question lingers, what if something is going wrong? In fact, something did go wrong back in 1978. Russian physicist Anat Borsky confronted an existence-altering accident at the same time as operating at the U-70 synchrotron on the Institute for High-Energy Physics in Russia. In such a condition, a proton beam with such velocity hit him, which passed through his skull starting behind his head and came out through the nostril. That was to be turned out to be a terrible story. Borsky saw a flash brighter than 1,000 suns. But then he had no instant concerns. The path left behind by the proton had left behind burning tissue and bone. Astonishingly, he remained conscious and even walked to our seeking remedy. Though the outcome turned into unsettling, it was additionally surreal. The proton beam prompted localized tissue harm, leading to partial hearing loss in one ear and facial paralysis on one side. Remarkably, Borsky's cognitive capabilities remained unaffected, and he continued his clinical profession. This incident serves as a grim reminder of the colossal power and capacity risks associated with particle accelerators. The risks associated with machines like the LHC should not be belittled. The possibility of catastrophic reactions in which even the very fabric of life could be altered is not just a plot device in science fiction but a real concern. But perhaps the most unnerving and the most curious question about the LHC is its potential to create a micro-black hole. Black holes are regions in space where gravity is so strong that not even light can escape. They suck up stars and remain one of the many mysteries, hidden deep within the far reaches of the cosmos. The fact that the LHC may create a black hole, even at a miniature scale, is a prospect both exhilarating and terrifying for scientists and the general public. Could a black hole created through the LHC grow uncontrollably and eventually consume Earth? Scientists have reassured the public that any black hole created within the LHC could be quite unstable and would disappear almost immediately. Even so, the very possibility of such a scenario has raised debates, fears, and awe at the immense power humankind possesses. To understand how the LHC should produce a black hole, it is necessary to know how particle accelerators work. In a case where protons are made to collide at near-light speeds, the energy produced is so pervasive that it warps the fabric of spacetime itself. The trampoline is stretched tightly. Then a heavy object is let to fall onto it. It bends, and in case the object is heavy enough, a well deep enough can be formed, pulling into it everything that gets too close to it. It thus helps in explaining what could be manifest at the LHC. Within the realm of quantum physics, where the rules of the universe can be bizarre and unpredictable, there is a theory that allows for the possibility of the existence of higher dimensions. If these invisible dimensions exist, then the experiments at the LHC may have access to them, creating a gravitational well capable of forming a microscopic black hole. In this weird interplay of particles, several of the greatest scientists of the time come in, including the late Stephen Hawking. Hawking writes to warn people of the real danger involving the Higgs boson, and at such high tiers of power causes instability. This instability might want to culminate into a catastrophic event, better known as a vacuum decay, the event which would destroy not just Earth but maybe the whole universe. In the book Our Final Hour, the renowned cosmologist and physicist Sir Martin Rees has expressed apprehension with the CERN experiments. He spoke of dangers from particle accelerators such as the LHC. Although Rees gave a low probability to those disasters, he mentioned that even the tiniest threat should be paid attention to. The stakes are high and the margin for blunders is razor-skinny. Scientists at CERN have done an immense amount of simulations and designed protection protocols so as to make certain that LHC operations stay as secure as possible. Even Brian Cox remembered those precautions. He detailed the need to reassure the general public that the energies involved inside LHC's experiments are properly within the range that Earth obviously reviews. According to him, the possibilities of creating a strong black hole are astronomically low. Should a black hole form, scientists say, it'd be so small and unstable that it could dissipate nearly immediately, emitting energy in a process known as Hawking radiation. It would be a fleeting cosmic show, long gone before we could hope to fully appreciate it. Others have gone even further, suggesting the LHC should create a door to another dimension or universe. This principle, though basically ignored by the clinical network, has nevertheless captured many imaginations. Could the LHC unconsciously unleash forces or entities beyond our comprehension? It was sensationalized in the media to open some sort of door to another world. Where is it rooted, and what would this mean, or does it mean, in terms of science? The notion of hidden dimensions is by no means new to physics. String theory, a leading candidate for a unified theory of everything, postulates that there may exist more than the usual 3 dimensions of space and 1 of time. These extra dimensions may be compacted or hidden from view, but under extreme conditions, they may be discovered. Now, take the LHC as one huge key, something that can open up doors which have been locked since the dawn of time. When protons collide at exceptional strength stages, they could, in theory, produce ripples in area time that monitor those hidden dimensions. But before we get too overexcited with theories of trade realities, it's crucial to observe that though the LHC is an extremely potent device, There can be absolutely no proof that might indicate this complex device may in any way unlock the gates to a different universe many in fantasy have supposed, or, further gullible rumors say, to hell itself. Yet, the mystery, together with the weirdness of quantum physics, keeps our minds fascinated. Should we be afraid of the LHC and any possible dangers? It is very easy to get caught up in sensational headlines and doomsday scenarios of global destruction. But the truth is that scientists at CERN are fully aware of the possible dangers involved. Every precaution is taken to ensure that their experiments are as secure as possible. The ability rewards in their research, inclusive of breakthroughs in our information of the universe, the invention of new debris, and the exploration of dark remember, are splendid. The LHC does not only showcase human ingenuity but also afford a peek into the very fabric of the universe. However, as with any major scientific breakthrough, the risks now must not be overlooked. We should approach such discoveries with respect, caution, and awe. The LHC epitomizes the edge of medical inquiry at which theoretical physics meets experimental reality. The potential this machine has to answer some of the most basic questions mankind has about the universe, such as the origins of mass and the nature of dark matter, is enormous. Despite all the safety precautions and extensive simulations, the LHC inspires nothing but a kind of awed caution. The enormous size of the apparatus and the electricity it generates is overwhelming. Every new test opens up an avenue not previously explored clinically. Most physicists continue to feel that LHC can never be harmful, but there will always remain some basic uncertainties. But what if sudden, new anomalies crop up that defy the understanding of physics and fact? The LHC is taking a toll on human knowledge, testing the extent of our control over the natural world. Its simulation of particle collisions at the universe's beginning raises pertinent questions about the very fabric of reality with increased urgency. Ongoing experiments at the LHC continue to challenge human ingenuity and can revolutionize our knowledge of the universe. Yet, there is also a continued tug-of-war between the imperative of discovery and the risks implicit in exploring new frontiers. As scientists go deeper into the study of particles, they might stumble upon a certain aspect of the truth which, by its very nature, would alter our conception of reality altogether. While the LHC's potential to free up new dimensions, exotic particles, or the secrets and mysteries of dark count is a source of tremendous opportunities, there are also associated risks which we are yet to understand. Might the experiments trigger effects that cannot be predicted and/or controlled? Public interest in the LHC often focuses on its potential for causing disastrous events or uncovering secrets which can change how humanity views its place in the universe. However, this fascination must not overshadow the meticulous, careful work being done by scientists. Despite the risks, the protection protocols reduce potential risks, and the experiments remain cautiously monitored. The LHC's goal is not to prove wild theories of parallel universes, but to explore the basic nature of our world. While speculation can also run amok, the focus remains on learning those very first building blocks of count. The LHC is among the most sophisticated tools we have in the direction of understanding the universe at its most basic level. The discoveries it is bound to make are expected to unlock improvements in everything from technology and medicine to even computing capabilities that could significantly make a difference in our daily lives. The search for dark matter, a mysterious substance constituting an awful lot of the universe, is just one example of how the LHC should for all time change our information of the cosmos. If scientists attain identifying the particle or particles that represent dark remember, it can result in a profound shift in our understanding of the universe's formation. Yet,